formulae of compounds, we use symbols to represent elements. So we also need some kind of symbolic representation of compounds so that we can easily write them out. But first, we have to recall that compounds are made up of elements that are joined together. That's basically what compounds are. So, in the same way, since we already have symbols for these elements, we can use these symbols from those elements that combine or join to form these compounds to then write the formulae for the compound. For example, we have water here. Water is made up of hydrogen and oxygen. So we simply use the symbol for hydrogen, which is capital H, and that of oxygen, which is O, and write out the whole formula of the compound water. Here is a model of a water molecule, and it represents the formula of water. We have a model here, and here we have a formula for water. Now, when we look at the formula for water, it also gives us the ratio of the number of each element that is found in that compound. So we'll see how much of each element was contributed to form this compound that we see here as water. For example, in this case here, if we look at hydrogen, we'll realize that there's a small subscript here. And with oxygen, there's nothing here. The 2 here for hydrogen represents 2 atoms of hydrogen. And the fact that we have nothing in front of oxygen, it simply means there is a 1 there, but it's a silent 1. We don't have to write it out. It means oxygen stands out as 1. For every molecule of water, we have then 2 hydrogen atoms to 1 oxygen atom. So the ratio is 2:1. In general, then, compounds will get their names from the names of the elements that are used to make them. Or, conversely, we can use the names of the elements that are found in compounds to develop the names of the compound. These are a few steps for naming compounds. The first step will be to identify the elements that are found in the compound. Like we did earlier with the molecule of water or the compound water. We identified oxygen, we identified hydrogen. The second step then, after we've identified the elements, will be to write the name of the metal first. If you go back to your periodic table, you will see that there are metals. Some elements are metals, others are non-metals, while others are semi-metals. The third step, if the compound contains only 2 elements, then we name the second element and we change the ending to "ide". It means after we've named the metal, we'll still have to name the second element, and we'll change the name of that second element to "ide". For example, sodium chloride. That is a name given to the compound formed between sodium and chlorine. Sodium is the metal, chloride is the non-metal, chlorine. Again, if the compound contains this time 3 elements, and if one of these elements is oxygen, then we name the element which is not oxygen after we've named the metal first. We name the element which is not oxygen, and we change the ending to "ate" to say that this compound actually contains oxygen, although we didn't name oxygen. The "ate" there points out that oxygen is existent in the compound. So for example, we'll have sodium bicarbonate. Now, there are some exceptions to this rules that we're following to name these compounds as 4 steps here. For example, if we are faced with an OH group in a compound, the OH group is called the hydroxide. And if a metal is then bonded to the OH group, the compound's name will end with "ide". For example, we have a metal, sodium, bonded to an OH group here. We have in this compound 3 elements: 1, sodium; 2, oxygen; 3, hydrogen. The compound is then called sodium hydroxide, although it has 3 elements in that compound. We refer to it as sodium hydroxide. Additionally, we could attach some prefixes to some compounds, to the name of some compounds. And these prefixes are there to show how many atoms of a particular element are found in that compound. For example, we could have the prefixes mono, which means 1, di, which means 2, tri, which means 3, and tetra, which means 4. Now let's look at these examples. We'll see here CO. Notice that there's only 1 carbon, 1 oxygen, because the suffixes or the subscripts have nothing there. It means there is 1 of each. 1 is mono, so I'll call this carbon monoxide. Carbon monoxide. The monoxide is to say that there's only 1 atom of oxygen which has combined with the carbon atom. In this case, I have 1 carbon, and my subscript here shows me that it's combined to 2 oxygen. Hence, I'll call this carbon. 2 is di, carbon dioxide, because now this time 2 oxygen atoms have combined with carbon atom. And here I have 1 atom of sulfur and 3 atoms of oxygen. Hence, I'll call this sulfur trioxide. 3 oxygen atoms have combined with sulfur. And here I have 1 atom of carbon and 4 atoms of chlorine. 4 is represented by the subscript 4 here. Hence, this will be called carbon tetra for 4, tetrachloride, carbon tetrachloride, because 4 chlorine atoms have combined with the carbon atom. In the same way, as compounds have prefixes, which are groups of letters which come before in the first part of the main word, and suffixes, groups of letters which come at the last part of the main word. So compounds also have suffixes. And remember, compounds are named according to their elements, the elements that are contained in that compound. So if the compound name ends in "ide", it means there are 2 elements in the compound. And we said earlier, if it ends with "ate", it means there are 3 elements, and one of these elements should be oxygen. Compounds have common names, and these common names, we use them in everyday language because they are more convenient. For example, water here. With water, we'll have no clue as to what elements are actually present in this water. Otherwise, the scientific name of water will then be di for 2, dihydrogen, for 2 atoms of hydrogen, monoxide, mono for 1 atom of oxygen, dihydrogen monoxide. Same applies with ammonia. With ammonia as well, we could not have any clue. With just that name, we can't have a clue about the elements that are found in that compound. So ammonia is a name that is commonly used in everyday language. Otherwise, it would have been nitrogen trihydride, for example, but we simply call it ammonia. Same applies with vinegar, which is the common name for ethanoic acid. And these common names are used much more often than we use actually the chemical or the scientific names.